In this last and final video for the introduction to statistics, we end in chapter 3, which is the F distribution and one-way ANOVA. So we're going to interpret the F probability distribution as a number of groups and sample sizes change. We're going to discuss two uses for the F distribution. We're going to conduct and interpret a one-way ANOVA test, and we're going to conduct and interpret the hypothesis test for two variances. So for hypothesis tests comparing averages of two or more groups, we have statisticians have developed a method called the analysis of variance, which is abbreviated as ANOVA. Although ANOVA uses variance in the computations, this is a statistical approach for determining whether or not the means of more than two populations are equal. The one-way ANOVA is used with the data that's categorized as one treatment or factor, which is a characteristic that allows us to distinguish the different populations from one another. So in order to perform a one-way ANOVA test, there are 5 basic assumptions that need to be fulfilled, and these were going to be in the homework. So please pay attention to this, write this down, have your notes out when you're doing your homework. Is that each population from which the sample is taken is going to be assumed to be normal, which means we don't have to have 30 pieces of data for each sample. All samples are randomly selected and independent. The populations are assumed to have equal standard deviations or variances. The factor is a categorical variable, and the response is a numerical variable. So when we are in the ANOVA, our choice for the null hypothesis will always be the means are equal. The means of the populations we are getting the samples from are equal, and the HA, that should be HA, not H1, is the means are not equal. The conclusion is to reject HO, which means that the means are not equal. Fail to reject HO means the means are equal. We're going to be doing something called an F distribution. An F statistic is a standardized statistic that measures the extent in which two model differences among means exceed that might be expected in a chance model. The F statistic is a ratio or a fraction, and there are 2 sets of degrees of freedom, one for the numerator and one for the denominator. We are going to be so excited because we're going to have Excel do all of the work for us, like all of it. So for Excel to do all the work for us, we are going to need in our Excel, we're going to need to click on data, and then we're going to come over here and see where it says data analysis. We're going to click on that. Now you may need to add an extension into your Excel if you don't see this data analysis. There are plenty of videos, do a search on the internet, extensions for Excel. When you do that, it's going to have something that pops up like this. Now, it may not be at the very top, so you just need to scroll up to be to the very top. We are going to choose the single factor, so we're going to click OK. And then after we choose single factor, we're going to have this pop up. So right here, you're going to click in here, and you're either going to enter the cells you are interested in, or you're going to highlight the cells that you are interested in with your data. So your data will be in your spreadsheet already, and you're going to highlight that. You're going to always choose columns. Now, if you highlight your top row, which is where your labels are, then you're going to click on that. If you don't click on that, then it is not going to grab that first row and consider it as labels. So if for some reason you don't click this, that's totally fine. You just make sure that when you highlight your data over here, that you don't include the row that has the labels. If you do, make sure you click on this. Here you're going to be entering the alpha that you're going to want, so what is required. And then right here is we need to tell you where you want to put this output. We like to put it on the same spreadsheet. So you can either do a new worksheet, you can do a new workbook. I'm going to put it on the same spreadsheet. And I'm going to click here so that I'm going to put it in the same place every time in this chapter. So it's going to come out with something that looks like this. So I had these different teams. Now here, because I did grab the names, so I did grab that top row that had the names team 1 to team 4. I grabbed all of that, And so that's why we have these names here. If I don't grab the names in my top row, then I'm going to get column 1, column 2, etc. It counted how many items were in each one of those columns. There were 3. It summed it. It gave me an average. It gave me a variance for all of those pieces of data. And then it gave me this. It gave me my F statistic, it gave me my p-value, and it gave me the critical value. These are the things that I need when I make a decision about whether or not I'm going to reject or fail to reject. Now, what you're not seeing, and I don't have any idea why I don't have this, is I should have had the example in here. So the example looks something like this. So I'm just going to draw it right now so you can see where this was coming from. So I had this example, which I had team 1, I had team 1, I had team 2, I had team 3, team 4, and then I had team 5. I had, in the first column, I had 36, 42, and 51. The second one I had 32, 35, and 38. My next column I had 48, 50, 39. Team 4, I had 38, 44, and 46. And Team 5 had 41, 39, and 40. So what I did was, in my Excel spreadsheet, this was already in there, is I highlighted this entire area so that I had my labels. And I clicked on the labels in the first row. When I did that, then it gave me all of this information down here. It gave me my average for each team. It gave me my variance for each team. And then it gave me my F value, my F, which is my test statistic. It gave me my p-value for that test statistic, and it gave me my critical value. Now, the question was at a 5% significance level, so at a 5% significance level, so my alpha was 0.05. Is there a difference in these numbers? And maybe these numbers represented the heights among the team members in not obviously in means or meters, because that would be way too tall. So maybe it was in their jumping height in terms of centimeters, or maybe it was in inches. So the question then is, at a 5% significance level, is there a difference in the mean jump heights among the teams? Now, since this is my F statistic, this is my test statistic, this is my critical value, this is my p-value, and the answer is fail to reject the hoe. So what does that mean for me? Well, that means that the means are, as far as we're concerned, the means of each one of these are equal, and we're going to fail to reject hoe based on both the critical value, the F statistic, and the p-value. So that's it. This is how we're going to end the quarter. Very nice, non-stressful actual calculator, and that's it.